Hello, my dear students and viewers. This is Dr. C. Jagdishwar Reddy, Assistant Professor in the Department of Electrical Electronics Engineering at PACE Institute of Technology and Sciences, Ongole. Today, we are going to discuss about Kirchhoff laws under Basic Electrical Electronics Engineering. The main objective of this lecturing is the student can able to learn Kirchhoff laws, that is Kirchhoff first and second law. After completing this lecture, the student can able to explain and measure the voltage, current, power in the electrical circuits. In 1845, German scientist Gustav Kirchhoff developed these two rules. It deals with the following: conservation of current, conservation of energy. The conservation of current we will call as a Kirchhoff current law. The conservation of energy we will call Kirchhoff voltage law. By using of these two rules, we can able to find the resistance, impedance, voltage and current in the complex electrical circuits. Kirchhoff statements. So Kirchhoff current law states that the total current entering into the junction is equal to the current leaving in the junction. We are going to take this diagram. I1, I2, I3, I4, I5 are the currents. I1, I2, I3 are entering towards the junction. I5, I4 are leaving from the junction. So we can able to write mathematical equation I1 plus I2 plus I3 minus I4 minus I5 equal to 0. So and also we can able to write entering in the junction, the current entering in the junction, summation of I in equal to summation of I out. It means that I out means that outgoing current. Kirchhoff voltage law states that the sum of voltage drop around loop is equal to the 0. We are going to take this one is a loop. A, B we have the one resistor, and B and C point we have the one resistor, and C and D we have the one resistor, D and A we have the one resistor. Each resistor we have that voltage drop. So we can able to write across the AB voltage drop, that is VAB, and BC voltage drop, that is VBC, and CD voltage drop is VCD. So voltage drop across this resistor, we can able to write VDA equal to 0. So according to statements, the sum of the voltage drops around closed loop is equal to 0. And also we can able to write in mathematical form summation of voltages equal to 0 in closed loop. So here and also we can able to write potential rise equal to potential drop. Summation of potential rise equal to summation of potential drop. So problem on KCL. So we are going to take one circuit. We are going to apply the KCL in the circuit. I am assuming this one is the first loop, this one is the second loop. The current flowing in this first loop will be I1, the current flowing in second loop will be I2. From this loop I am going to write the equation I am starting from here onwards. Minus 2 volts, 2 into currents here entering will be, I am going to assuming this one is I1, here is 2I1, 2I1 plus 2 into I1 minus I2. I1 minus I2. This current direction should be like this. Second loop current direction to be opposite to the first loop current direction. So that the current is subtract with I2. I1 minus of I2 into 2. So we will write equation like this. So after that 2I1 I am going to write like here. After that plus 2 into I1 minus I2. This 2 I am going to sending out that side. So after that 2I1, 2 into I1 minus of 2 into I2 equal to 2. Finally, we can able to write this equation from this loop. 2I1 plus 2I1, 4I1 minus of 2I2 equal to 2. This one I am going to assuming equation 1. From the first loop we got equation 1. We are going to take second loop. The current flow across the second loop will be I2. From the second loop we are going to write the equation. Here is 4 into this loop current will be the I2 plus 2, this 2 ohm resistor into I2 minus I1. The current of direction of I2 from this loop will be this direction and I1 will opposite to that I2 direction. So we can able to write I2 minus of I1. So from that 4I2 plus 2I2 minus of 2 into I1 we can able to write like this. After that I1 I am going to write first, then I am going to write that 4I2 plus 2I2 will give that 6I2. It is equal to the 0. I am assuming this one equation 2. We solve the equation 1 and 2. Equation 1 and equation 2 we can solve here. In this equation 1 we are going to divide with 2 so that we can able to rewrite that equation 1 as 4I1 will be there. It will come here is a 2I1 because of we are going to divide with 2 here. So here is 2I1, I2 will be there. We are going to divide with 2. So we will get the minus of I2. Here 2 will be there. Here we are going to write is a 1 because of we are going to divide with 2. So rewriting this equation 1 such like this. That is 2I1 equal to 2I1 minus of I2 equal to 1. So after we are going to take equation 2, I am going to write the equation 1 like this. This is the 2 equation I am write as it is. After solving this 2, we can able to find the I2 value will be 0.2 amps. So I1, 2I1 minus 2I1 goes to cancel. Here is the plus 6I2 will be there. Plus 6I2 will be there. Minus I2 will be there. So we will get the 5I2 equal to 1. I2 equal to 1 by 5. So we will get the 0.2 amps. That current we will call as a I2 current. So after that getting I2 current, we can substitute this one into equation 1. The equation 1 is that 4I1 minus 2I2 equal to 2. In that we are going to substitute this I2 value. Here we are going to substitute 4I1 minus 2 into I2 value. That is a 0.2 amps we are going to substitute here. So if we substitute this one I2 value, we will get I1 is the 0.6 amps. After that I1 and I2 we can able to find the I3 also. What is that I3? I3 equal to I3 equal to I1 minus I2. So what is the I1 we got here? 0.6. I1 is we got this 0.6 minus of I2 we got the 0.2. If we subtract that I1 minus I2, we will get the I4 0.4. 0.4 we got from this equation. So what are that our statement states that Kirchhoff current law, sum of the entering current equal to leaving current. Here I am going to assuming I1 will be the entry current at a junction or node. Junction, or we can call this one as a node. So here is that I2, this will be, we are going to assuming I3. So sum of entry current equal to leaving current. The leaving currents are here I2, I3. So we can able to write I1 equal to I2 plus I3. If you substitute whatever that values we got from this I1, I2 and then I3. So this will apply sum of the entering current equal to sum of the leaving current, it will matches. Satisfied. Problem on Kirchhoff voltage law. We are going to take the circuit. Here we are going to, we know already, that is Ohm's law is V equal to IR. We know Ohm's law is the V equal to IR. So from this circuit we are going to find the R equivalent value. R equivalent value we need to find. So these resistors are in series. These resistors are in series manner. The resistors are connected in series. So the resistance are we are going to adding all. So that is R equivalent equal to, we get R1 plus R2 plus R3. So if we add all the resistor, we got the value is R equivalent value 8 ohms, 2 ohms, 2 plus 4 plus 2. We will got the 8 ohms. That is the R equivalent value. According to Ohm's law, I equal to V by R. So I is there. This one we are going to sending to here, this side. So I equal to V by R. We will form this equation. So we know already V value, that is the 2 volts, and R value we got here is the 8 ohms. So 2 by 8. We will get the current is 0.25 amps. Because of here all the elements are in series connection, the current will be the same across the all elements. So that current is the 0.25 amps. The 0.25 amps flows across the all the element because of all resistors are connected in series. So I need to find here is the drop across this resistor. Thus resistor I am going to assuming V1. So here is the voltage drop is V1. Here is voltage drop across this resistor I am going to assuming V2. This is a voltage drop across this resistor will be V3. So how much voltage drop will be there? We need to find out here. That is V1. So V1 formula, V1 equal to I into R1, because R will be the same across the all resistor because of here resistors are connected in series. So V1 voltage drop here will be V1 equal to I into R1. So what is the I value here? We got here 0.25 amps. V2 equal to I into R2. I will be the same for all that drops here. So V2 equal to I into R2, V3 equal to I into R3. So I will be the common here, the resistance only vary. So according to that I am going to write here V equal to I1 into R1 plus I into R2 plus I into R3. Potential rises, total potential rise equal to total potential drop. So here applied voltage will be the 2 here. So drop will be, here I am going to write I will be the 0.25 into 2 plus I is 0.25 into 4 plus 0.25 into 2. So if you multiply this, we will get that 0.5. To multiply this, we will get the 0.5. If 0.25 into 4, we will get that 1. 0.25 into 2, we will get the 0.5. If we add all these drops, we will get the 2. That is equal to applied voltage. So the KVL statement is satisfied. The potential rises equal to potential drop in a closed circuit. Thank you.